Hello students, in this video I'm going to cover question number 4 and question number 5, and this question is all about the Lenz's law and how we are going to apply the Lenz's law in the different situations. As I remember, I teach you the Lenz's law number of times, but just for a review, just go through the rule. Lenz's law, as per the Lenz's law, the direction of induced current is such that it opposes the change. It opposes the change of magnetic flux. Let's say if your current I1 is increasing, then I2 is in the opposite direction. Always remember, increase, then the other will decrease. Okay, opposite direction. If first is decrease, then the other will increase, means this will support you. Okay, in this, what you need to remember, the same direction and the opposite directions. Let's say this is increasing. Can you understand that both the directions are opposite directions? Yes or no? Increasing, see the direction, both are opposite direction. But if they are decreasing, then the direction should be the same. Here, decreasing, direction should be the same. Clear, guys? Okay, I want to tell you something which you can just remember and solve your questions. The first thing, the shortcut I told you, scan, and I thought you remember this thing. S means south, C means clockwise direction, A is your anti-clock, and N is for your north. Okay, now I'm going to add something for your understanding, for your next level. That is called DU. Here D is equals to down and U is equals to upward direction. And here downward direction. You need to understand. Okay, now I'm going to teach more part is downward and upward. Guys, till now we learned about the motion of the magnet. In the previous videos, what we have learned, this is the magnet, it is going this side or it is moving this side. So what is the impact on the circuit? Yes or no? But now the question has changed. Now I'm going to tell you something new. The second part, let's say if magnetic field is given. Let's say this is your particular area. This is the area. Okay, here the magnetic field is given. Okay, there are the two type of magnetic field. I'm going to teach you each and every aspect. First, magnetic field, that is your magnetic field. We know we have two type of direction. One is cross means downward means towards, means inside. You can say downward or inside. Clear? And second is dot, which is outside or upward. Clear? Okay, so here we have the cross means downward, which is negative z-axis. Clear? I will write here negative z-axis, positive z-axis. Clear? Till here clear? Okay, so you need to understand the technique so that we can apply it. Okay, I will add a page here and we will start the technique. I told you scan DU, SCANDU. Okay, so it means downward is with the south and upward is with the north and anti-clockwise, and down is with clockwise and south. What you need to understand, basic things. Flux is your BA cosine theta and V induced is negative d phi over dt. I just want to tell you something so that it will become very easy for you to solve the numericals and the directions. Very, very easy. Let's say case 1. Case 1. This is your cross. It means in which direction you are right now? Tell me, huh? Direction. Given direction. Given direction. So given direction is your cross. It means south. Yes or no? And I can write downward. Clear? Okay, let's say there is a body which is start to enter into it. Case A, entering into magnetic field. Now what is happening? It is going to enter. So if it is entering, just think and tell me what is happening. Can I say area is increasing? Yes or no? Okay. So can I say flux is increasing? Yes or no? It means V induced is declining. Do you understand? Sure. If V induced is declining, means what we get? We get the result. What should be the result? Tell me. The result should be the opposite directions. One if like this, the other should be like this. Opposite direction. Yes or no? Okay. Now, first understand. If the given direction, just try to understand. Huh? What is your given direction? Given direction. Tell me. Given direction is cross. It means inward. Yes or no? So what should be the result direction? Result direction should be dot. That should be outward. So that we can say it's an opposite direction. Yes or no? Till here understand? If this is your induced direction, I will just highlight this one. Result direction, or you can say the induced direction. Induced direction. Then what should be the result? The solution is the direction of induced current is, okay, dot is with north. Yes or no? And north is with anti-clockwise. Yes or no? Clockwise. So the final result is your anti-clockwise. Guys, clear? Understand? Okay, I will add one more page and I will take one more example so that it should be clear to you. Huh? Okay, now take the same case. Huh? Case 1. Case 1. Okay, this is cross. Okay, first what we have learned, let's say this is the body, it is enter. So case 1, enter. Okay, this much we understand, that we have the cross, then opposite direction should be the dot. Dot gives you north and north gives you anti-clockwise. So cross gives you south and this gives you clockwise. Clear? Okay, now exit. Now take the case that it is here and it is moving out. So second case, exit. Just think, given direction as per the question, cross. Cross means south. Yes or no? Okay. Now what will happen? Can I say area start reducing? Yes or no? Okay. Can I say flux starts declining? Then V induced should increase. Means same direction. That should be the same direction. So same direction means what we have already? X. So given is given direction X. Resultant direction, result should be X. X means south. South means clockwise. South means clockwise. Yes or no? And this is your answer. Clear, guys? Okay, I'll take one more question so that it will be easy for you to solve the numericals. Let's say now the case 2. Let's say we have dot. Okay, take the same question. First, enter. Okay, so what is your given direction? Given direction is dot. Dot means north, yes or no? And north means anti-clockwise. Fine. Okay, now what will happen? It is increasing. It's moving inside. Okay, moving inside means area increase, flux increase, V induced decrease. Yes or no? Easy to understand. Okay, if V induced increase, then what should be the direction? Direction should be opposite direction. So what should be the opposite of dot? The answer should be yes, yes, yes. The answer should be cross. That should be, you can say it should be inward. Yes or no? So can I say cross means south and the result is your clockwise? Clear? Fine. Okay, now take the same case, exit. It is moving out. Then what will happen? Just tell me. Given direction is your dot. Dot means north. Moving out, area decline, flux decline, V induced increase. Increase means same direction. Same direction means dot. Dot means north. North means anti-clockwise. Yes or no? Clear, guys? Now you understand how to solve the Lenz's law, all the directions. Clear? Okay, now this is something very good, huh? See what this part, and this is specifically for your MCQ 5, not 4. This is used for 5. What exactly we have to learn? Let's say we have a wire, piece of wire, and it's moving in the magnetic field. Guys, as we know few things, we know the flux, which is BA cosine theta. Yes or no? Okay, let's say if area is changing, then how to solve this factor? There are the two factors what you need to understand. Let's say this is your wire, and if it starts moving, then there are the two factors on which you need to understand. Can I say area is equals to length time width? Yes or no? And if the wire is moving, so can I say length is L? What should be the width? How much it covers? How much it covers? Think, huh? So the distance should be velocity time. Yes or no? Do you understand this part? Okay, so can I say total area is equals to any area A naught plus what should be the area? Can I say length into width? Width is width, which is equals to your velocity multiply time. So if I find V induced, which is minus d phi over dt, so can we say B is constant, cos of theta is constant, dA over dt. If you solve this, you will get BLV. You will get BLV. So what are the things you need to remember? What are the major things? As we know, V induced is negative d phi over dt, and in case of wires, we can say BLV. We can directly use this formula also. Okay, guys, fine. Okay, there is no need to go into the detail of all these things. If you understand, that is fine. If you don't understand, you can just remember the formula, and when you are going to use this formula, whenever you see any wire moving in the magnetic field, is it fine? So guys, this is the major thing, on which you need to focus. Okay, now time for the questions. This is something very interesting question. Okay, I'm not reading the question. First, try to understand. As per the picture A, Okay, change the color. And picture B. Can I say there is a change in area? Change in area, yes or no? Tell me. It means flux, or first step should be the current. The area is declining, flux is declining, V is increasing. Yes or no? Okay, let's read the question. Okay, a while loop is placed in uniform magnetic field over a period of 2 seconds. The loop is shrunk, means area is declining. Which statement about the induced potential difference is correct? Okay, we need to identify which is correct one. There will be some induced potential difference. Yes, we already understand that if area is changing, there should be the potential difference. Okay, read the second statement. There will be no induced potential difference. No, answer should be wrong. Okay, third, there will be no induced potential difference. Wrong. There should be. Fourth, there is no induced. This is also wrong. So the answer is A. Clear, guys? So we can simply say there is a change in area. Change in area gives the change in flux, and that will gives you the potential difference. So you can write like this: V induced is equals to negative d phi over dt, which is equals to B cosine theta dA over dt, and there should be the negative sign. Clear, guys? Okay, now time for the next question. Okay, a square conducting loop. A square conducting loop with very small resistance is moved at a constant speed. Okay, velocity is given. So I can write V constant. Okay. From a region with no magnetic field. Okay, there is no magnetic field, through a region of constant magnetic field, and then into a region with no magnetic field. Okay, so what he said, let's say this is your case A, this is your case B, and this is your case C. Here no, or I can write magnetic field is 0. Magnetic field B is 0. Okay, B is 0, B not equals to 0, and here magnetic field B is 0. Okay, as shown in the figure, as the loop enters. Okay, this is something interesting. If the loop enters, so some part is inside and some part is outside. The same thing now which I told you earlier. As the loop enters a magnetic field, what is the direction of induced current? As the loop leaves the magnetic field, what should be the direction of induced current? Yes, guys. So what he is trying to ask you, the both cases. Case A. Case A, when enters. When this is enter. Okay. So in terms of enter, first step, what is the given magnetic field? So the given, just check, this is, what is this? Cross. Given is cross. Clear? So when you are entering, what will happen? Area increase. So if area increase, flux increase, V induced decrease. What should be the result? Opposite direction. So what should be the opposite direction? Dot. Dot means north. North means anti-clockwise. Yes or no? Easy. Just apply scan. Scan du. Clear? Okay. What is the second case? Exit. Second case B. Exit. So same thing. You have X is given. Okay, so area decline, flux decline, V induced goes up. It means same direction. Same direction means X. X means south. South means clockwise. Yes or no? Understand? So this is your first answer, anti-clockwise, and the second answer is clockwise. Clear, guys? Okay, now moved with the next question. Yes. Okay. Read this carefully. A conducting rod is pulled horizontally by a constant force. Okay. And force is given F is equals to 5 Newton along a set of conducting rails separated by a distance A. Okay, this is very important. A distance. Can I say distance A is 5? What is this distance? See, mention here. So can I say this is your length also? Can I say distance A is equals to length? Yes or no? 0.5 meter. Okay. Two rails are connected and no friction occurs between the rod and the rails. A uniform magnetic field. A uniform magnetic field. So given B is equals to 0.5 Tesla. Okay. Is directed into the page. Into the page means just check the direction. Into the page. Into the page. What does it mean? X. X means south. South means clockwise. Yes or no? Okay. The rod moves at a constant velocity. Okay, velocity is given, speed is given. Okay, V is equals to 5 meter per second. What is the magnitude of induced potential difference? So what we are looking for? V induced, which is equals to negative d phi over dt. And I told you, whenever there is a case of wire moving inside the field, BLV. Okay, so place the values. What is the value of B? Okay, 0.5. L, distance is 0.5. Velocity is 5. Solve this. Fast. 1.25 volt, and this is your answer. Clear, guys? Fine. Okay, now we have the next question. Just apply this and solve it. Calculate the potential difference. Calculate the induced potential difference. Okay, we are looking for V induced, which is equals to negative d phi over dt, which is equals to B times L times V. Clear? Between the tips of the wing of a Boeing, this with a wingspan. Okay, this is something good. Wingspan means there is a plane and which has the wings. So can I simply say the length is given, L is 64.67 meter. Okay. When it is in level flight at a speed, okay, speed is, velocity is 913 kilometer per hour. Okay, guys, now we need to change it. 913 multiply 5 by 18 meter per second. Okay, what is the rule? Rule is 1 kilometer per hour, which is equals to, okay, if you solve 1 multiply 10 power 3 divide by 3600 second, so which gives you 5 by 18 meter per second. So what you can write, 1 kilometer per hour equals 5 by 18 meter per second. Clear? Okay, and see, magnetic field is also given. B is given. B is equals to 5.0 times 10 raised to negative 5 Tesla. Okay, V induced, we are looking for, place the value. V induced is equals to B times L times V. 5 multiply 10 raised to negative 5. Okay, what is the length? 64.67 multiply 913 multiply 5 by 18, because in meter per second. Solve it. So the answer should be 0.820 volt. So this is your option number A. Clear, guys? Understand? So guys, till here I covered question number 4 and question number 5. So I thought this topic is very easy and you learn new thing about the direction and how to identify the direction of induced current. And the second equation is whenever a wire or rod or length is moving like this type of question, whenever this is moving inside the magnetic field, we have a simple equation: V induced is equals to B time L time V. Simple formula, just apply it and solve it. Clear guys?